When you add this 3 for 6 times, you are getting 18. But then when you multiply 3 into 6 also, you are getting the number 18. What does the first law of indices tell us? When the bases are same, the powers can be added. If there is no bracket, then it means that 3 has to be multiplied 2 times. So this comes up to a to the power of 9. Hello everyone, I am Purnima, faculty in the Department of Commerce, Vidhyaashram First Grade College, Temple of Excellence, Mysuru. In this session, we will be having a discussion on Unit 1, Session 1, that is Theory of Indices. Let us see what does this mean. Now, first let us understand what is the meaning of the word indices. The basis of indices is important for many calculations. In this chapter, we have discussed the laws of indices. So, in this theory of indices, we will be having a discussion on what do we mean by indices. So, indices are nothing but it is the plural of the word index. So, first we should understand what do we mean by index, and then we will have to understand what do we mean by indices. So, index is nothing but it is the power of a number. Suppose there is a number called a to the power m. So, this is a number. So, where a can be any number, a can be 2, 3 or 4, and this m, this represents the power. What do we mean by power? Power is nothing but the number of times this a has to multiply. Now, let me give you an example. Suppose I write 4 plus 4 plus 4 plus 4 plus 4. What is the answer you are getting? 4 plus 4, 8, 8 plus 4, 12, 12 plus 4, 16, 16 plus 4, 20. So, when you add 4 5 times, you are getting 20. Now, the next example I will be giving you 3 plus 3 plus 3 plus 3 plus 3 plus 3. Now, what is the answer you will get? 3 plus 3, 6, 6 plus 3, 9, 9 plus 3, 12, 12 plus 3, 15, 15 plus 3, 18. Now, this kind of addition, whatever result we are getting, the same result we can get through multiplication also. Now, do you understand what I am telling? Suppose we write, instead of writing 3 plus 3 plus 3 plus 3 plus 3, so what I will do is 3 into 6 is 18. Now, this number 3, it has been repeated 6 times. So, when you add this 3 for 6 times, you are getting 18. But then, when you multiply 3 into 6 also, you are getting the number 18. So, this result, whatever we get through addition, the same result we can get through multiplication also. Now, we have seen here that repeated addition, the same result can be got through multiplication. So, if you are adding 4 plus 4 plus 4 plus 4 plus 4, so in other words, you are writing 4 into 5, you are getting 20. So, the repeated addition, whatever result you are getting, that we can get through multiplication also. Now, suppose there is repeated multiplication. What I am telling is, suppose I write 3 into 3 into 3. What is the answer I will get? 3 into 3, 9. 9 into 3, 27. So, this repeated multiplication, whatever you are getting, this can be got with the help of the power. So, instead of writing 3 into 3 into 3, I will write 3 to the power 3. So, this power, whatever the power, so this is the number. So, this number we call it as the base, and the number which you are writing on top of the number, that is called as the power. So when I see this power, I should understand that this number has to be multiplied 3 times. Suppose I write 2 to the power 5. Now what does it indicate? It indicates that this number 2 has to be multiplied 5 times. So it will be 2 into 2 into 2 into 2 into 2. So what is the answer I am getting? 2 into 2, 4, 4 into 2, 8, 8 into 2, 16, 16 into 2, 32. So this is the number I am getting. So whenever there is a number which is raised to another number, this number is called as the index. This is called as the index and this is called as the base number. Now, in theory of indices, indices is nothing but it is the plural of the word index. So, the number which is raised to another number, so that power is called as the index and the base is called as the base or the radicand. Now, let us see what is written in this. So, what is the meaning of a to the power n? So, just like as I just wrote now, 3 to the power 3 is equal to 3 into 3 into 3. So, that will be 27. The same way, if I am writing a to the power of n, it means a into a into a into a. How many times I should multiply? N times. Okay. So, are you following? Suppose I write 4 to the power 4. What does this indicate? So, I should multiply this 4 times. So, 4 into 4 into 4 into 4. So, this comes up to 4 into 4, 16. 16 into 4, 64. 64 into 4. 64 into 4 will be equal to 256. So, in this way, we should understand that suppose a is any real number. So, a to the power of n. Suppose they have given us a number a to the power n. It means that a has to be multiplied n number of times. So, whatever the number is given in the power, so that many times we have to multiply this base number. So, if a is any real number and n is a non-zero positive integer, then a to the power of n is n times you have to multiply and a is called as the base and n is called as the index or the power or the exponent. So, we should understand that the number which is written below, that is called as the base number, and the number which is written above the number, that is called as the power or the index number. So, now here in these indices, we have certain laws of indices. So, whenever we are talking about multiplication, we talk about the indices. So, whenever we have these indices, there are certain laws which we should understand. There are certain laws of indices which if you understand, you will be able to deal with these numbers better. Now, let us see what the first law tells us. Now, as per the first law, if a is any non-zero real number and m and n are positive integers, then a to the power of m into a to the power of n equals a to the power of m plus n. So, first thing, let us see what they have given here in the sentence. If a is any non-zero real number. So, what are real numbers? Real numbers are any number. It may be any number between 1 to 1000, 1 to infinity. Any number can be a real number and they are two positive integers. So, positive integers means any number. So, what do we mean by integer? So, any number with the plus or a minus sign. So, it may be plus 1 or minus 2 or plus 3. So, all these we call as the integers. So, whenever they are speaking of positive integers here, positive integers means plus 1, plus 2, plus 3, plus 5. So, any number they are called as positive integers. Now, if A is any non-zero real number and M and N are two positive integers, then A to the power of M into A to the power of N equals A to the power of M plus N. Now, here we should understand that the bases should be equal. Now, for example, in this example, I am writing 2 to the power of 3 into 2 to the power 4. So, in this, what can I do? How can I simplify this? So, it will be 2 to the power of 3 plus 4, that is equal to 2 to the power 7. So, have you followed here? So, whenever the bases are similar, so the bases should be same, then the powers can be added. So, we can add both the powers. Now, I will give you one more example. 3 to the power of 2 into 3 to the power of 1. So, what will be the answer? 3 to the power 4. So, what does this 3 to the power 4 mean? So, it means 3 into 3 into 3 into 3. So, this will be equal to 3 3s are 9, 9 3s are 27, 27 into 3 is 81. So, in this way, we should understand that when the bases are same, the powers can be added. So, I'll give you one more example. Suppose it is 5 to the power of 3 into 5 to the power 1. So, what will be the answer? 5 to the power of 3 plus 1, that is equal to 5 to the power 4. So, what does 5 to the power 4 mean? It will be 5 into 5 into 5 into 5. So, 25 into 5, that is 625. So, in this way, we should understand that when the bases are same, the powers can be added. So, when the powers are added, so whatever number you are getting, that 2 to the power 7, so it means that this 2 has to be multiplied 7 times. Or this you are getting 3 square into 3 to the power 1. So, it comes to 3 to the power 3 plus 3 to the power of 1, that is 3 to the power 4. So, 3 into 3 into 3 into 3, that comes up to 81. So, in this way, I hope you have all understood the first law of indices. Now, what does the first law of indices tell us? When the bases are same, the powers can be added. So, any number for that matter you can take. Suppose I write 10 to the power of 1 to 10 to the power 2. What will be the answer? 10 to the power of 1 plus 2. That will be 10 to the power 3. So, this will be 10 into 10 into 10. So, this will be 100 into 10, that is 1000. So, in this way, we should understand that indices are, what does the first law of indices tell us? When the bases are same, the powers can be added. Now, again, let us see here. I'll give you one more example. So, 2 to the power of 5 into 2 to the power of 6. So, what does it come up to? 2 to the power of 5 plus 6, that is 2 to the power of 11. Now, I'll give you one more example. Suppose I write 3 to the power of 2 into 2 to the power of 3. Can we add this? No, we cannot add here. Why? Because the bases are different. So, here I have as the base I have 3, here we have 2. So, it cannot be added. Not to be added. So, suppose I write 4 to the power of 0 into 4 to the power 4. What is the answer I'll get? 4 to the power of 0 plus 4. 4 to the power 4. Now, the next one, suppose I write 5 to the power of 2 into 5 to the power of 8. So this will be 5 to the power of 2 plus 8, that is 5 to the power 10. Now, if you can expand all these expressions, what will you get? So it will be 2 into 2 into 2 up to 11 times you have to multiply this 2. So, but here you cannot add here. Why? The bases are different. Here the bases are same, that is why I have added. Here also bases are same, so that is why I have added. So 5 into 5 into 5 up to 10 times it has to be multiplied. Only then we will get the answer. So I hope you have understood the first law of indices. Now what does the first law of indices tell us? A to the power of m into a to the power of n equals a to the power of m plus n. So when the bases are same, the powers can be added to get the result. Now, let us see what the second law tells us. If a is any non-zero integer, real number, and n and n are any two positive integers, so a to the power of m divided by a to the power of n, then we get a to the power of m minus n if m is greater than n. Now, suppose you have to divide two indices. Like for example, I am giving you an example here. Suppose I write 2 to the power 5, 2 to the power 3. Okay. So here you can see that bases are common. So here both are same. Here also a and a are same, m and n. So here 5 it represents m and 3 represents n. Okay. Now, which is greater here? 5 is greater. So what will I do? I will write 2 to the power of 5 minus 3. That is 2 to the power 2. So this is the answer. So here they have written here. So if m is greater than n, a to the power of m by a to the power of n equals a to the power of m minus n. So for example, in this example only, so 2 into 2 into 2 into 2 into 2. So 1, 2, 3, 4, 5 times I have written, I have expanded this. Now 2 to the power 3. How many times I should write? 3 times. So 2 into 2 into 2. Now when I simplify, I will chord this. What is remaining here? 2 to the power 2. I am getting the same answer here. So I can just deduct the power from this and I'll get the answer. For example, one more example. I'll write 4 to the power of 5 divided by 4 to the power 2. 4 to the power 5 divided by 4 to the power 2. Now what will I write? 4 to the power of 5 means 4 into 4 into 4 into 4 into 4. So 1, 2, 3, 4, 5. So 5 times I have multiplied 4. Then again 4 into 4. So 2 times I have multiplied 4. So what will I do is, I will cancel these 4's. So what is remaining here? 4 to the power 3. So this is the answer. So in other words, if I can apply this law of indices, I can simply write 4 to the power of 5 minus 2, that is 4 to the power 3. I am getting the same result. So whenever you have to divide two numbers, or whenever you are given a number with a power, so and if you have to divide, then the best way is to just deduct the number which is greater. So if m is greater than n, then this rule will apply. So a to the power of m by a to the power of n equals a to the power of m minus n if m is greater than n. Next, I'll write here a to the power of m by a to the power of n equals e to the power of m minus n when m is greater than n. Now I'll write here 5 to the power of 4, 5 to the power of 3. What will I get? 5 into 5 into 5 into 5 divided by 5 into 5 into 5. So if I am simplifying this, 1, 2, 3, 4, 5. What is the answer I am getting? Only 5 to the power of 1, that is 5. Now if I do this law of theory of indices, I will get 5 to the power of 4 minus 3, that is also equal to 5 to the power 1. So we should understand that a to the power of m divided by a to the power of n equals a to the power of m minus n. So when m is greater than n. Now the next, if m is less than n, then what will be the answer? Now I will give you an example, the same example. So 3 to the power of 5 divided by 3 to the power 10. Now here m is less, n is more. Here m equals 5, n equals 10. Now what can I write? How will I expand this? 3 into 3 into 3 into 3 into 3. So 5 times I am multiplying this 3, and here I will be multiplying it 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times I am expanding this 3 to the power 10. Now I'll simplify. What is left in the numerator? Only 1 is remaining. Here 1, 2, 3, 4, 5, 6. So this will be equal to 1 by 3 to the power 6, or 1, 2, 3, 4, 5. So it will be 1 to 3 to the power 5, or I can write it as 1 divided by 3 to the power of 10 minus 5, that is 1 divided by 3 to the power 5. Now the next one, third law. So I hope you have understood the first law. What does the first law tell us? A to the power of m into a to the power of n equals a to the power of m plus n. Now suppose I have to divide a to the power of m divided by a to the power of n, then it will be a to the power of m minus n. If m is greater than n. If n is greater than m, then I will be writing 1 divided by a to the power of n minus m. Now the third law. What does the third law tell us? A to the power of m whole to the power of n equals a to the power of mn. So suppose I write 2 to the power of 3 whole to the power 2. What does this simplify? According to this law, what they are telling, a to the power of m whole to the power of n equals a to the power of mn. So what should I do if I have to apply this? So 2 to the power of 3 into 2, that is 2 to the power of 6. So this is the answer. Now in case I have to expand this, what will I write? 2 to the power 3 into 2 to the power 3. So I will get the same answer. So 2 to the power of 3 plus 3, that is 2 to the power 6. So if you are writing a to the power of m whole to the power of n, so a to the power of m you will be multiplying n number of times. So you will get a to the power of mn. So m into n. So it will be 2 cube into 2 cubes. So it will be 2 to the power of 3 plus 3 or 2 to the power 6. So this is the third law. I'll give you one more example. Suppose I write 3 to the power 2 whole to the power 2. What does this signify? 3 square into 3 square. So this will be equal to 3 to the power of 2 plus 2. 3 to the power 4. Or instead of doing that, I will do 3 to the power of 2 into 2. That is 3 to the power 4. So this is the third law of indices. So whenever a power is raised and the whole power is raised to another power, then these two powers can be multiplied. So if the whole number has to be multiplied, only then we can apply this third law of indices. Now, for example, I'll give you an example. 2 to the power of 5 into 2 to the power of 6. What is the answer you get? 2 to the power of 5 plus 6. 2 to the power 11. Now, suppose I write 2 to the power of 5 divided by 2 to the power 6. What will be the answer I'll be getting 1 divided by 2 to the power 6 minus 5. That is 1 by 2 to the power 1. Or this will be equal to 1 by 2. Now, suppose I write 2 to the power of 6 divided by 2 to the power of 5. This will be 6 minus 5. That is 2 to the power 1. Now, again, I have one more. 3 to the power of 5 whole to the power of 3. This is the third law. So, it will be 3 to the power of 5 into 3. So, this will be 3 to the power of 15. So, in this way, whenever a question on indices is asked, we have to apply these laws of indices in order to simplify these numbers. So, these indices, they will help us in calculations of very large numbers, and in turn they will also help us in using the log tables also. These indices are helpful for finding out the value of through the help of log tables also. Now, the fourth law. Now, what does the fourth law tell us? So, AB to the power of m equals A to the power of m into B to the power of m. Now, here there are two numbers here. See, 2 into 3. They are two different numbers. Now, the bases are different. So, up till the third law, we could see that the bases were the same. When the bases are same, then only then you can add them, or you can subtract them, or you can multiply them. But here, in the fourth law, we have different bases, but we have a common power. The power is common for both of them. If you get this type, you can write 2 square into 3 square. Now, what does this 2 square mean? 2 into 2 into 3 into 3. So, this will be 4 into 9. That is 36. Now, do you understand this? So, whenever you have two bases but a common power, then that power should be given for both the numbers. Now, suppose I write 5 into 4 to the base 2 to the power 2. So, with this can be written as 5 to the power 2 into 4 to the power 2. So, 5 into 5 is how much? 25 into 4 into 4 is 16. So, you can simplify 25 into 16, whatever is the number. So, in this way, we should understand that AB to the power m equals A to the power of m into B to the power of m. Next, the fifth law. What does this fifth law tell us? Now, here they have a fraction. So a by b to the power of m. Now, if there is a fraction and if it is raised to a power, then what should we do? It will be a to the power of m by b to the power of m. Okay, suppose I write 1 by 2 to the power 2. So, what can I write here? 1 square by 2 square. So, this will be 1 into 1 by 2 into 2, that is 1 by 4. Now, if you can apply the same rule, I'll give you one more example. I am writing 2 by 3 to the power 4. So, what can I do if I want to expand this? I have to write 2 how many times? So, this will be 2 into 2 into 2 into 2 divided by 3 into 3 into 3 into 3. So, I am expanding this to 4 times, 3 also 4 times. Now, next, so I'll give you one more example. 1 by 5 to the power 3. What will be the answer here? So, it will be 1 to the power 3 by 5 to the power 3. So, this will be 1 into 1 into 1 divided by 5 into 5 into 5. This is 1 by 25 into 5 is 125. Next, I'll give you one more example here. Suppose I write a by b to the power of 4. A by b to the power 4. This will be a to the power 4 by b to the power 4. So, this will be a into a into a into a, b into b into b into b. So, in this way, this is the fifth law. So, if you can see that these laws are very helpful in our calculations, or whenever we have to simplify any number which has been raised to a power, or all these indices whenever they are given. So, we can apply these laws and make our simplifications. Now, there is one more rule regarding these indices. Now, what does this tell us? So, the power raised to a power. A power function can be raised to a power as given below. Suppose I write power 3 whole square. Now, I have just written a to the power 3 whole to the power. This is not whole to the power, only 3 square. So, there is no bracket here. If there is no bracket, then it means that 3 has to be multiplied 2 times. So, this comes up to a to the power of 9. Why I got a to the power of 9 here? Because it is 3 square. So, it means that I cannot multiply this 2 into 3. Why I cannot multiply? Because there is no bracket here. So, if there is a bracket, then I can write a into 3 into 2, that is a to the power of 6. But since there is no bracket here, they have simply written a to the power 3 square. So, this means that a to the power of 9, that is 3 into 3 I have to do, and as a result I am getting it as 9. Now, this will not be same as the whole function being raised to a power. The power will multiply as given below. A cube, the whole square will be a to the power 6. Now, 4a square whole to the power 3. Now, this is a to the power m. In this example, if you can see here, this relates to this theory of indices, that is the fourth law. So, ab to the power of m equals a to the power of m into b to the power of m. Now, 4a square whole cube. So, this will be equal to 4 cube into a square whole cube. So, this will be 4 into 4 into 4 into a to the power of 2 into 3. So this will be equal to 4 4s are 16, 16 4s are 64 into a to the power 6. So this will be 64 a to the power 6. So this is the answer. So in this way, we can understand that. So any number which has raised to a power, so we have to just raise it to that power. So a to the power 3 whole square will be a to the power 9. But then if there is a bracket, then it makes a lot of difference. So a to the power of 3 whole to the power 2, it will be a to the power of 3 into a to the power of 3, a to the power of 3 plus 3, a to the power of 6. So we can see now. Again, let us have a quick revision of what we did today. Now, what does the first law tell us? A to the power of m into a to the power of n equals a to the power of m plus n. So, this is the first law. Now, in the second law, it tells us that a to the power of m by a to the power of n equals a to the power of m minus n when m is greater than n. Now, when a to the power of m by a to the power of n equals 1 by a to the power of n minus m when n is greater than m. Then, in the third law, a to the power of m whole to the power of m equals a to the power of m into n. Now, in the fourth law, it tells us that ab to the power of m equals a to the power of m into b to the power n. In the fifth law, a by b to the power m will be a to the power m by b to the power m. So, these are the 5 laws of indices. So, if you can understand these 5 laws of indices, it will be very helpful for us when we do our simplifications of these index numbers. So, if I can give you an example here. So, 5 to the power of 3 into 5 to the power of 2, it will be 5 to the power of 3 plus 2, 5 to the power 5. Again, if I can give the same example here, so it will be 5 to the power of 3 minus 2, 5 to the power 1. Suppose I write 2 and 3 here, it will be 1 to 5 to the power 1. Now, if I write here 5 to the power of 3 whole to the power of 2, it will be 5 to the power of 3 into 2, 5 to the power of 6. Now, suppose I write 5 into 4 whole to the power of 2. This will be equal to 5 to the power of 2 into 4 to the power of 2. That will be equal to 5 into 5 into 4 into 4. Now, if I write 5 by 4 to the power of 2, it will be 5 to the power of 2 by 4 to the power of 2. It will be 5 into 5 by 4 into 4. So, these are the 5 laws of indices. So, when we do the problems, we will be able to work out all the simplifications with the help of these 5 theory of indices. So, with this, we come to the end of this session. Hope you have all understood this theory of indices. Thank you.